circular linked list using double linked list. So by definition, circular linked list is using double linked list is, so here you can, as you can see in the diagram, so last node's next pointer pointing to head node. So last head node is here D, so D is next will point to head node, that is the first node of the circular linked list, that is A, and the first node's previous node to last node. So first node's edge address point to the first node's edge previous pointer will point to D's address last node. So we can imagine in circular linked list as anti-clockwise and clockwise movement. So we can move in both direction. So forward direction using next address and backward direction using previous node or previous link. Now we can define the node. It is of type struct node and it is having data of integer type int data. Then it is having struct node previous pointer and struct node next pointer. Okay, so as you have seen, usual node is A, so as previous pointer's address will be D's address and as next address will be B's address. And so instead of previous you can use left pointer, and instead of next also you can use right pointer. So for convenience we have used previous and next pointer in this exercise. And simply you can check the head address with null. If initially the first address of the circular link is null, then we will return to program, main program. Now we define another pointer p, struct node star p, then p will be assigned with head address. So now we'll initialize count is equal to 0, which is of integer type, another count variable, and we have initialized as 0. So using next address, next link, we will traverse till the last node and simply count. Just we have done in single linked list. You can traverse till last node and we will increment. We will move forward using p is equal to p next. So and then count will be incremented as count is equal to count plus 1. Now the head address will be passed to our address to our program. So that address we can assign to p's also. So p now contains the head address. Now p will traverse till the last node. How do you travel? P is next is equal to not equal to head. So p is next to not head. So at a, so p is next is equal to b. So that condition is satisfied. So that's why you will execute two instructions inside the while loop. That is p is equal to p next and count plus plus. So count will be incremented, count is equal to 1. Now p is equal to p next, p will jump to next address, that will be b's address. Now the aqua blue pointer or the arrow mark shows that we are moving in the forward direction using next pointer. Yes, now p is at b and now we'll check here. P is next is equal to not head, so b is next is equal to c. So this is the while condition is satisfied, so count will be incremented. So count will be 2 and p is equal to p next. So p will jump to c's address. Okay, so this is already executed. So we are at c, count is equal to 3. Now we will check the condition of while loop. p next to not head, so p is equal to p next. So next address will be d, so d will jump to d's address, and count will be incremented. So count is equal to 3 now. Okay, at this condition count is equal to 3, and we will jump to next address, that is d. Now at d count is equal to 4, and here we will check 1 second p next will not head, and then we will try to jump to next address. So when we check at this point at d, p is next is equal to head, so already that is false, so while loop breaks here, so we will stop here. Okay, so p next is equal not to head, that is false, so current node is at d, so count is equal to 4, and we will stop here. Okay, so executing this program, so the count value is 4, so this simply returns the number of nodes in the circular linked list is equal to 4. Okay, this implementation is done using next pointer, and we traverse in the forward direction. Now the same thing can be done using previous link. So alternatively you can go backward using previous link, and we'll check the same condition, p previous is equal to p arrow mark previous not equal to head. So you will go in backward direction using previous link, and then you can count the node also, increment the count, and each time at 1 by 1. So the same code we can write here, struct node star p. So we'll head address will be assigned to p, count is initialized as 0, that is integer value. Now we'll check a condition in the while loop, p previous will not equal to head, p is equal to p previous, and count plus plus. Okay, now we'll start here at a, p is previous is d, so p is previous not equal to head, that is true, so we'll go inside the while loop, count will be incremented, so count will be 1 now, and p is equal to p previous, so p will be at, after this point p will be at d, we are traveling in the backward direction, so we will be at d. So yes, now we are at d, count is equal to 1. Now once again we will check the condition, p previous not equal to head. So whether we have reached our destination a, starting going backward, so we'll check whether we have reached the edge address. So once again that condition satisfied, that is true, while loop condition is true, so count will be incremented, and before that p is equal to p previous, so p will go backward to c. So yes, now at c count is equal to 2, now p is equal to p previous, so while reaching at c the count will be incremented, so count will be 3 here. Now from c we'll check once again the condition, p is equal to p previous is equal not head, so current node c, so count will be incremented, so that will be 3. Now 3 plus 1 will be there, then count will be 4, and p is equal to go backward to b's point, b's address. Okay, so now here b and s, the count will be incremented, count is equal to 4, now we are at b. Okay, so now we'll check once again, p previous will do not equal to head, so obviously p is previous is equal to head, so that condition holds false, so we will stop here. Yes, so p will be previous equal to head, so this condition breaks here, so while loop breaks there, it will stop, and the count value will be returned, so count is equal to 4, that's why the number of nodes in the circular list is equal to 4. So from this example we can see that by using both forward and reverse direction you can traverse using doubly linked list, and since this linked list is circular in nature, at the last node you can go to the head past node, and from past you can traverse to the previous node by simply using previous or next node. Okay, so if you are at A, you can go to last node by simply applying A's previous is equal to D. So without traversing till last node, as you are doing in the single linked list, you can jump to last node from first node by simply using this previous pointer. So that's why you can traverse from head node to last node in order of 1 in the double link using double linked list. That is one benefit or advantage of using double linked list for implementing circular linked list. Okay, so at uh, at any specific node we can go forward using next link, and we can go backward also using previous node. This is one more advantage. The address space will be increased, but traversing is very useful in both direction, in forward and backward direction. Okay, so now this is the basic example. Now we'll see our legacy operation like insertion, deletion and traversing. Traversing almost we have covered using this exercise for counting number of nodes, but you can implement also some specific operation for traversing also. We'll see in next class. Now this is one basic operation. This is one special case for insertion of a key in circular linked list. Okay, so insert at begin. So what do you mean by insert at begin? Means you are given a first address or head address of a circular linked list. Now before that head address, you want to insert another node of type this double linked list type, and we want to insert before head node or the first node. So the prototype of this function will be void insert at begin struct node double star head, and the key value, new key value will be int key, that is an integer type. Now this is our given linked list, that is circular in nature. Already each node is having both pointers or links, previous and next, and last node is pointing to first node since it is circular, and first previous node also linked to the last node. Okay, now let's begin. Now we'll create a temp node first. So temp is struct node. We'll allocate the size of struct node by using malloc, by calling malloc function, that is the inbuilt function in C, malloc size of struct node. Now here suppose that is E, the temp node is E. Now we have to reassign or the links of these temp nodes, both previous prev and next address, and we have to break the address of the last nodes and first nodes address, first nodes previous address and last node's next address, and you have to reassign those address to with temp node, and then you can successfully implement insertion at begin. Now how do you do now? Now we have already declared a temp node, and I allocated the memory. Then now we have before that. Okay. Yes. Now this will be executed fast. So head address will be assigned to P address. So P will be a temporary pointer. The head address will be point to that. So now you can see the temp previous is equal to P previous. Now P is at head. So P is previous. That is already D. So this link will be broken. Okay, so now the temp previous will be First we will assign temp previous to p previous, and p is previous, that is d is next will be temp address. So now since temp will be the new head address of the circular link list, so last nodes will address will next address will point to temp node. So for that we have used here p previous, p is at b, p is at a now. So p is previous is equal to d, so d is next is equal to temp. That means temp's value will be new temp's address will be given to last node's next address. And the first yellow mark line, the link has been established. So since temp will be the start node, so its previous node will be last node. So simple p is previous, mean that is d's address will be the address of temp's previous address. This yellow mark statement. Okay, so those two links has been established. Now we can go further and see that temp next will equal to p. So now temp's next already we have established. So now temp's address temp will be new head, so temp next is equal to p, and we can assign temp is equal to head is equal to temp, star head is equal to temp. So that is not written here, but we can assign head address to temp. That means the temp address will be the new start of this circular list. So we can see the example here, and the written code here also we can check and verify and simulate also, execute also. Okay, so we have already begin void insert begin struct node star double star head key. Now temp will be another the new temporary node, so we will allocate the space using malloc function. Now we'll check the temp is has been properly allocated or not. Then temp data is equal to key, p head address will be given to p. Now we have executed the three statements we have already seen. Temp previous will do p previous, p previous next will do temp, and temp next will do p. Here runtime complexity will be order of 1. In case of single linked list, we have to travel to the last node, and then last node's next link will be broken and then assigned to the temp nodes. But here we can simply travel to the last node from the first node by using p previous. So the aqua blue line you can see p previous next is equal to temp, that breaks the link of the last node's next address and pointing to temp address. Okay, so that's why simply you can see here there is no loop or nor we are traversing to till the last node by forward, either in forward direction or backward direction. So you no need to go to the last node. Okay, so simply traversing to the last node you can go from first nodes. So that is why this is order of 1 runtime complexity. So this is the starting phase of this circular linked list implementation using double linked list. You can go further for generic insert operation at any position, then insert at the end, which is also a special case of insert at any position. Okay, in the next class. Thank you.